Imagine yourself as a child growing up. For many people, whether you live near a forest or just had trees in your yard, you probably remember them on the landscape. Whether you played around them, used them for shade, put a playhouse in them, or walked through them on a path, the trees of your childhood hold a space in your memories. Now, imagine those same memories, but with completely different types of trees. Maybe the pine tree that you had a swing tied to is now a leafy maple tree, or maybe that maple tree is now a palm tree. Pretty hard to imagine, right? This scenario may seem a little extreme, but climate change is beginning to alter the natural range of some species, causing them to migrate to more suitable locations. The scenario I just described may soon become a reality. Hi there, my name is Sarah Auerbach, and the title of my podcast is Facilitation for the Future. I want to talk to you about a situation that we haven't had to deal with before in our existence: climate change. A variation in climate is a normal occurrence throughout time, but never before in recorded history has it been so abrupt and so rapid. What exactly is climate change, you ask? To keep this simple, climate change is the gradual alteration of the global climate due to human activities, namely the burning of fossil fuels and deforestation. The burning of fossil fuels, such as coal, pumps carbon dioxide into the atmosphere, which gradually raises the temperature of the planet. Trees normally help to absorb this excess carbon dioxide, but the consequence of their removal is that more carbon dioxide is left to remain in the atmosphere. It is predicted that by the end of this century, the mean temperature of the planet could rise 4 to 11 degrees Fahrenheit. Due to climate change, scientists, foresters, ecologists, and biologists have begun to notice a change in forest stand development around the country. As forests go through the normal process of regeneration, that is, growing new trees as old ones die, it is being observed that the new trees that would normally be comprised of species that are appropriate for that particular area, climate, and disturbance regime are being replaced with trees that are more appropriate for warmer climates. In many places, warmer climate trees are beginning to migrate north towards areas that would previously have been too cold for them. As temperatures in the north begin to increase, these northern areas are becoming more hospitable for them. However, this is a problem. Just as certain species of trees are moving north with the warming climate, trees currently in the north that prefer colder temperatures may begin to die out. You may ask, since the Earth's climate has been fluctuating for millennia, is this migration just a normal part of the global cycle? Well, yes and no. While migration has happened before, the rapid climate change we are seeing now may force species to migrate faster than they are naturally capable of doing, making them susceptible to extirpation or local extinction. So, what, if anything, should we do? Should we sit back and let nature take its course with the potential consequence of losing entire species? Or should we intervene and attempt to preserve forests as they are for as long as we can, even if most forests will almost certainly be altered by warming temperatures, regardless of our efforts? This is a question that researchers with the Nature Conservancy in northern Minnesota have been asking. Why Minnesota? As it turns out, forests in northern Minnesota are in a unique geographic location. They are at a climatic boundary that separates boreal forests, primarily consisting of aspen, spruce, fir, and birch common to forests in Canada, and northern hardwood forests common in areas to the south and east, consisting of white pine, maple, and oak trees. Many species in this area are at either their northern or southern range limit, which makes them especially sensitive to changes in climate. These places where different biomes meet will be some of the first to feel the effects of climate change and to see changes in flora and fauna. In the past, management in this area strove to increase diversity by replacing conifers that had been removed due to extensive logging and large fires. However, modeling has shown this strategy may not be appropriate in a climate change landscape. In their gradually warming home ranges, these boreal species may not survive. To project the future of forest composition, a spatially explicit forest ecosystem model called Landis 2 was used. Results showed that the composition of forests in northern Minnesota would almost certainly change in the future. This change would include a movement towards a less diverse forest with a heavier maple component. Trees currently native to the area, such as white spruce, balsam fir, and paper birch, may become extirpated from their area regardless of any management actions to prevent this. Also, modeling showed a possible loss of black spruce, red pine, and jack pine in a high carbon dioxide emission scenario. So now what do we do? Continue to manage to increase the population of boreal species, even though modeling suggests that they will most likely continue to decline? Or should we switch our focus to just maintain these species on the landscape in the face of climate change instead of increasing their numbers? This second scenario would focus on managing for a diverse forest made up primarily of trees that models show will do best in predicted future climates and will ensure that a productive forest will exist to provide for timber, recreation, and cultural values. What does this mean for stand dynamics? If we do nothing, it could turn ugly. Climate change is happening rapidly, faster than what natural tree migration can support. Since the last ice age, it has been observed that trees can move at a pace of roughly 100 meters per year. With the forecasting of climate change, it is predicted that trees would have to move 100 times that speed at 10 kilometers per year. This pace is not something that trees can accommodate. The boreal species may begin to die out before the hardwoods from the south can move in to replace them. A resulting dead forest would barely resemble the forests we see today. Forests could turn into brushlands and could be overwhelmed by fast-moving pioneer species. If less precipitation accompanies the warming weather, the forests of Minnesota could transition to semi-arid grasslands and oak savannas similar to Nebraska. We can possibly help these trees get to where they need to be by planting species in advance of their arrival, so that when migration happens, they will have a head start with a population already growing. The Nature Conservancy and the University of Minnesota are taking on this problem in an effort to see how forests will respond when planted with a mix of native species and genetic material from a wide geographic range in an effort to improve diversity and resiliency. Their goal is to plant species to see which ones are most likely to succeed in the warming forests of the future. The name of this project is Adaptation Forestry in Minnesota's Northwoods. Depending on the outcome of this project, it could spark a marked change in forest management in response to climate change. The big question here is, will facilitating the movement of certain tree species help, or will we be creating a new problem by interfering further? Will certain species become extinct without our help, or will they adapt to climate changes on their own as they have in the past? Or is something in between these two options more feasible? There's no right answer here, as we are navigating uncharted territory. The best things we can do as we wait to weigh our options is to take steps to reverse the damage that has been done as much as possible by reducing carbon emissions and helping our forests become more diverse and resilient to the effects of climate change. As far as northern Minnesota goes, instead of seeing the iconic northwoods trees such as balsam fir, black spruce, birch, white spruce, jack pine, and red pine on your next visit, you may be greeted by hemlocks, beech, maples, oaks, and white pine. Without question, unless climate change can be slowed, the forests and the memories of future generations will look very different than what we see today.